Hello friends, welcome to Learn, Apply and Build. In this course, we are going to study a very interesting topic on machine learning, that is object detection, and also TensorFlow. We are going to learn how an object detection model is made using TensorFlow, but we are going to ignore the math behind it. So this is for the guys or the girls, those who want to ignore the math and just get started with the project. So let's deep dive into the project, into the course, and happy learning. Hello friends, welcome to Learn, Apply and Build. To get started with what is machine learning and a small introduction to machine learning. So what is machine learning? Machine learning is a set of tools that are broadly speaking allow us to teach computers how to perform a particular task. Let's say for example, I want to segregate my emails to spam and no spam. And it's a tedious job for me. I can train my computer to do that. So machine learning is a diverse and an exciting field, and there are multiple ways of defining it. An artificial intelligence view, a software engineering view, and then there's a stats view. The stats view deals with all the statistical data, which you can just analyze and summarize and clean and then just remove some statistical analysis out of it. So that involves some sort of cleaning data. And the major part of machine learning is that training your data. So here we are going to train our data using the Google's Teachable machine, which will allow us to train our model based on masks and no masks. So basically that's a supervised learning. We'll come to that. What is supervised and what is unsupervised learning. But the Google Teachable machine, as I said, it will allow you to train your model within just 5 minutes without you getting involved inside all the mathematics which is involved at the back end. So the types of machine learning which are there are supervised learning, as I told you earlier. That is, supervised learning is you have the trained data, the data is labeled. For example, the data which we are going to use now is masked and unmasked. So the labeled data is going to be trained and we'll have a model. And then once we use the model to predict that whether the person is wearing masks or no. So that is what we are going to do. But then there are other machine learning also, that is unsupervised learning, reinforcement learning, and some other more. For examples, like some examples are semi-supervised learning, the time series forecasting, anomaly detection, active learning, and so on and so forth. So we are going to just focus on the supervised learning, that is masked data set and an unmasked data set, and then getting the model trained, getting how the images are to be downloaded using the web driver, and lots of code. So let's get started and let's get into the course. Happy learning.
Uh,
Hello friends, welcome to Learn, Apply and Build. In this course, we are going to study a very interesting topic on machine learning, that is object detection, and also TensorFlow. We are going to learn how an object detection model is made using TensorFlow, but we are going to ignore the math behind it. So this is for the guys or the girls, those who want to ignore the math and just get started with the project. So let's deep dive into the project, into the course, and happy learning.
Folder wherein we'll save this as a mask detection folder. So once this folder is created, I just save this file, download images.py inside this folder. Now, so what do I need is I just open that folder for our simplicity. So it's in development and it's mask detection. Open. Finally, I have that file. So here what we are going to do is we are going to download the images, whatever query the user is entering or we are entering, using scraping, that is web scraping. So for that I just import a driver, that is Selenium. So from Selenium I'll import WebDriver and from BS4. Now what is BS4? BS4 is Beautiful Soup 4, and I'll import Beautiful Soup, and I'll import requests. I don't think so we require the requests, but then for like the code, I'll just import URL lib dot request, that I'll be requiring. So I'll have URL lib dot request. I'll import time. I'll import I'll import time, and I'll import sys, that is system, and also import OS. Now after importing all these libraries, we want the query to be coming from the user. So I'll just create a variable that is, let's say, download, and then download is equals to, for taking an input we just have input, and then whatever prompt we want to be displayed. So what do you want to download? Let's just ask the question with a semicolon, with a colon. Okay. Now after that is downloaded, this query will be put in Google, right? So what would be the site name? So let's say the site is equals to, it will be the site will be, let's say it will be from Google. So I'll have to copy and paste this link here, which I've already written it somewhere. So this will be the link, and yes, so this download query goes here, and it goes and searches in the Google homepage. Right now, let's start providing the driver path. So I'll just provide comments first, providing the driver path. So driver path is, I have to provide for the driver to on its own go and download the using the Gecko driver. So I'll provide here driver is equals to web driver, and I'll be using for Firefox for that. So web driver dot, and I'll get Firefox here. So WebDriver dot Firefox, and then once that is done, I'll have an executable path, executable path is equals to, and my executable path is the link. So what I need to do is I need to copy and paste the Gecko driver here. So I need to go to the files, go to downloads, and check the Gecko driver here, go back to download development, and I'll search for the mass detection, and in this folder I'll just paste this Gecko driver. So I have to provide the path for this Gecko driver here. So just get this copy path and paste it here. That's it. So we have provided the driver. Now what we do is we'll pass the site URL to this driver. So pass site URL to the driver. Right? So how do we do that? Is driver. So we have created an object here. This object will use driver.get, and then whatever the site URL is, so site. So this will fetch the site now. Now the logic for downloading the images will come. So we'll write the logic. So let's say we have I is equals to initially 0, and then while I is less than 7. So this condition is always met. So I'll just go ahead and driver.execute the script, this one, execute script, and what the script is I have already written it here. That's I don't have to type it, so I just I'll just copy and paste it here. So the downloadable, so I've already done this. So I'll just walk you through the code. So this is a while loop. We are entering the while loop, and then we try to execute this, and then try to, like, for clicking more, show more results on the button. So now what is this? Is this we have taken from the HTML tag, the div2, div3, and this is for the clicking to search. Like we have searched driver dot. We have found the element using the path, that is using the HTML inspecting the page, and then using Beautiful Soup we have parsed the HTML parser, like the driver.page source, and then close the driver once our work is done. And in the end the count is 0. Now for I in image tags, so whatever images are collected, they are stored in the image tags to find all, and then using those URLs they are downloaded. So it will print count plus is equals to 1 means the number of images being downloaded, it will be printing those and saving. So let's say we save this and give it a try. So we run the script, and as soon as we run the script, it will ask us what do you want to download. So I say that we are detecting masks, so I will say faces with masks. So as soon as I hit enter, it will ask me that the gecko driver, it cannot be opened or something, but then I want to open it, so never mind, we'll just rerun it again, clear this, and when you rerun it, faces with masks. So we'll have to go to the settings. For MacBook users, we'll have to go to the settings in security and privacy. We'll have to allow it anyway. So once it is allowed, we can just clear it, and then we can rerun this. So faces with masks, and we just hit open here. So as soon as I hit open, what it will do is it will on its own go and open Firefox, as we have used the Firefox, and it will interpret that we wanted masks, and it will just start downloading and let us know how many images have been downloaded. So we'll just collect some roughly around 200 images or so of that would be the limit for downloading the images, and it will show us how many images have been downloaded. So just wait for a while, and so it is just collecting all the tags which were there for the mask images, and it will start downloading here. So it has already started downloading here, and we can see that the downloaded images are approximately 82, 87, 91, 98, 105, and so on. So as soon as you keep on clicking, the images are getting downloaded, like, and we'll stop at 200. Let's say we can stop it at 210, so that we can just, yeah. So now we can just stop by Control and C. So if you just go ahead and look at like reveal in Finder and like look at the images, so you can see that there are people with masks which are shown here. So we'll be using these images, whatever images we have collected, and which are there in the folder. So let's just say we can just create a folder of masked images. So just select this all images, and like we will just paste them, copy, and we'll create a new folder, let's say mask, and we'll paste them here, and we can delete all the images which are there here. Oops. We can delete all these images. Okay, we deleted the folder as well. Okay, so So we have the folder here. Just keep the folder aside, and then we can leave that those images as it is. As such, the images will be refreshed. The images would be changed here. Now the other images which I want is like just faces of people. So I just give the query in that way, in that format, and these all images of the masks will be replaced. So we don't need to worry about it. So just clear, and we just give it again a query. So the query will be faces of people. We just need faces, any type of faces, right? That's it. So let's say we'll collect these images as well, 200 sort of images of people, let's say people smiling and people from different countries and actors and actresses, anything. So we just collect all sorts of images here. So these images will start changing now. So yeah, we can see here that the images are updating on their own. So these all images have now, the masked images have now been changed to normal images of the people, faces of the people. So let's say we'll again stop here at 210, roughly around 210 or something, and then just press. So now these images which were there, we can just go ahead and okay, we'll just close this, or else the mask is I don't require. Now I just open this image, revealing finder, and I can see that these images are now non-masked images. So this is the script, or this is a way that we collected all the images what we want the model to be trained on. So let's say that we'll use these images for masked and unmasked, that is categorizing or classification of images, to build a model for classifying an image to, or a webcam image or a live video to masked person or an unmasked person. So in the next video we'll see how to train a model, how to make a model which is very quick, very smooth and very efficient. So till then, thank you, see you in the next class. Once we've collected all the images, let's just create a model out of it. Let's use Google's Teachable machine. So let's just get started. When you open it, it's very easy. The UI and the field is very easy. You can connect with your drive, or else open an existing file or an existing project, or else you can just go to an image project if you have images to be trained on. You can have an audio project if you have audio based files and using your microphone or some sound files, and you can also use some images or webcams for the post detection project. So these are the projects which Google has come up with as of now. So we have to classify the images based on masks or no masks. So we'll select the image, and we'll use the standard image model, which will have 224 cross 224 pixels color images, and we can export to TensorFlow, TensorFlow Lite and TensorFlow.js. So the model size would be something around 5 MB, and it would be accurate enough that it can classify that whether you are wearing a mask or no, and we'll see that in a while. So what are our classes? Our classes are that you are now classifying the model, you are training the model to classify your images into masks or unmasked. So a person is wearing a mask or not wearing a mask. So you can have, yeah, wearing mask, and the second one can be not wearing mask, right? And if you have webcam, then you can have, like, you can select webcam and then you can take images. You can also add classes to it, like if you have like different people from different countries, if you want to classify, then you can have the keep on adding classes, and then the model will be trained. But here we have only two classes, that is wearing a mask, that is masked people or unmasked people. Now to upload the files, like you just have to go to the folder or else select upload and then just go to the folder where we had downloaded earlier. Like remember, we had downloaded in the development folder, we had mask detection, and then we had all the wearing masks. So these were the images which we had downloaded, so we can just select them and just drag them here. So all these images, they'll be pasted here. So these are the images which are people wearing masks. Now we'll upload the images with the people who are not wearing masks. So we can just select we can just move this to bin, we don't need this anymore, and then we can just go down and select all these images from here which are people smiling and people, normal people, and then just select them, drag them here, and then that's it. So we have roughly around 217 images here, 210 images here. So we can just delete some of the images here if you want. So we can just go down here, and so these images are already done. So we can just go down here, and what we can do is we can just delete some of the images, like 7 to 8 images we can just delete, so that we are at par, like 210 images we want here. So these are, so don't worry, but your model will be trained exactly on the images or on the classifications which you require. So these are also considered as masks, right? So this image is considered as a mask, the person is wearing a mask, but that's not a mask which we are looking for, right? So the model will be trained on that many number of epochs, that many number of times, right? So let's just say, like, we have all images 210 and 210. So that's done, wearing masks and not wearing masks. Now we just come here to the next step. Now we've collected all the images, we've put them in the in the training data set, like we've collected the data set as such. Now when we come here to train the model, we just click on advanced and just check. So what are the number of epochs? The number of epochs are how many times the training model will run, or it will execute, or it will interpret for your model to be trained, and how many number of interpretations it will be doing inside each epoch. So if you just come here, then it'll show you that what is an epoch. So one epoch means that each and every sample in the training dataset has been fed through the training model at least once. So if your epochs are set to 50, for example, it means that the model you are training will have like entire training dataset 50 times. It will traverse through the whole dataset. So now what I'll do here is I'll set the epochs as 100. Okay, so it says that if your epochs are 100, means it means that the model will be training through the entire training dataset 100 times. Okay, so if you have larger number of epochs, that means that the model prediction would be more accurate, right? And the batch size, like if you have batch size, so what are the batch sizes? Batch is a set of samples used in one iteration. So how many samples do you want to use in one iteration? So if you have, like, I've selected here 16, so if you have like that means that the data will be split into 80 divided by 16, that is 5 batches. So once all the 5 batches have been fed, so it will be divided into batches of 5. So like that it will be divided here, and the learning rate will keep it as it is, and rest everything as it is, and then we'll just select train model. So if you see here, if you check, your model is being trained here, the training has been started, and we'll get a warning, or we'll get a message that you must not leave. So here you can see here the epochs have been started. We have 100 number of epochs and the time for it, and the model is being trained. This is probably the fastest way to complete a project related to training, or TensorFlow and Keras and machine learning project, which will give you a hands-on, and which will be allowing you to showcase your capabilities based on the machine learning. If you don't want to learn the math at the back end, at the math which is going on while training, what is happening here exactly, so we don't want to know that. Okay, so now the model has been trained. I can export the model, but if you see here, I'm not wearing a mask, and if I'm not wearing a mask, it is showing me that not wearing mask is 100%. But now if I check here, if I wear a mask, you will see that wearing a mask is now 100%. It has classified the image as I am wearing a mask now, and I'm not wearing a mask now. So our model has been trained now successfully, and now I can go here and export the model. So to export the model, I can just have the TensorFlow, not JS, I'll just download it here, TensorFlow Lite, and TensorFlow Lite or TensorFlow. I can just select quantized. For these are all HTPU and quantized, they are for your Android application sort of a thing. And your TensorFlow, it will work with your Python projects, with your Python code, the TensorFlow trained model. So you have a Keras and a saved model. So what it suggests you that, see, convert your model to Keras.h5 model. Note the conversion happens in the cloud, but your training data is not being uploaded. Only your trained model is being uploaded, and this converts your model to a TensorFlow saved model. Note the conversion happens in the cloud again, and the training data is not being uploaded. Only your trained model has been uploaded. So what we can do is we can have a .h5 model here, and we can download the model. So it is converting the model into a .h5, and we'll get the model being downloaded. So these are the steps for training your model. There can be n number of use cases, and there can be n number of trainings which you can carry on using this model, which can be as quick as possible. Like you saw that it just took like 5 minutes to just complete a training of these many number of images, and it was so accurate. The classification of a masked and unmasked is so accurate at this step. So in the next lecture so we have downloaded the folder, which is the model has been downloaded. So in the next lecture we'll see how to use this model over an image, so in a live code, in a live webcam. So we had already seen it, but we can see that in the next lecture we'll just have a code in Python which will just visually represent that, okay, the face will be detected, and it will show that, okay, this person is wearing a mask over it, and a person is not wearing a mask. So see you in the next class. Thank you so much. So let's create a file named masks.py, and in this file I'll just include some lines of code. I'll import some libraries to be fetched, that is tensorflow.keras. From tensorflow I'm importing keras. So if you remember that we have the inbuilt model which was created was from TensorFlow, and it had the name tensorflow.h5. So we are creating the model, and we are importing the statement, these imports. Now we have a couple of other imports like numpy and cv2, and from the process underscore labels, we import the generate labels. So we'll get back to this folder which we require, so in a couple of moments. So we are just creating the numpy, and using computer vision 2, that is cv2.video capture. So it will be a live video captured using the TensorFlow, and we'll be attaching the name of the model which we have just created, just changing the path. So we'll just paste, I'll just need the not the image, I don't want to open the image. I'll just copy and paste the folder first here. So I'll go to the folder and paste the folder here in this directory. It will be called the converted underscore keras, which we had got from the model creation, and once that folder is done here, we have it here. It will be we'll just try to rename this first. So rather than just copying the path here, okay, we'll just copy the path here, but this has too many spaces. So initially what we'll do is we'll just rename this as converted, and I just rename this as converted, so that it's easy for us to just copy the path. And now we can just copy the path for the Keras model which we have created. uh, we'll come to the labels.txt in a while, where we have the process labels file. There we'll have to check with the file, where there we'll have to check with the labels.txt. And if we remember, like, the labels which we had were labels were of wearing masks and not wearing masks. So this is the path, and then just some code which we need to create the labels, generate labels, which we are using from the process labels. And see, we have imported the generate labels. So those are the labels which will be there in the label.txt. And the code, like, while this condition is met, while true, we'll just forward through the code, and we'll just convert some images and some frames around the images. We'll just generate some frames around the images, and then if not, we'll just continue. And using computer vision, we are creating a rectangular frame of this size inside the image which we'll generate, and then it is converting the image to an array of np using numpy. And once that is done, we'll just predict using our data, and that's the end of the model, or that's the end of the file which we have here.
The code which we have already written for the masks. So we have this folder here which has the converted, which we just edited here, and we have copied the path from the Keras model here in the directory which we have. Let's just ignore this currency, as that was another project which we were working on. And now we have the masks.py. So this is the file which we have just now seen. And so as I was talking to you about the labels, so this is a function which we have created, def generate labels, which will have a dictionary of labels. So coming back to, okay, we have this labels, which is like inside the converted folder, and inside that there is labels.text as label. We are opening that, and then we read that and split them. Now print the lines, and then for this we hold and line dot split, and we are returning the labels. So from that, if you see, the labels are wearing mask and not wearing mask. So here, if I want to try and run this program using Python, I can just write python 3 masks.py. So as I run this here using through the terminal, and inside the terminal, it'll just take a while to just process, because it has TensorFlow, which is a heavy library for Python. So it'll be using that. And once it is allowed to access the video through the video capture, I'll be going back and I'll check the frame which is generated. So we can see here the frame is being generated, and it's not that much accurate as it was, but if I go inside the frame, I can clearly see that it predicts that, yeah, I'm not wearing a mask. But now if I just take a mask and I wear it, it'll show me that I'm wearing a mask. So it is so accurate, and it is so quick about the model. So this is the execution part of the project, and the final output. For this, you will need to download, or you will need to install TensorFlow, which will be pip3 install
TensorFlow, and I'll be just mentioning that here if possibly if you want it. So you will be needing TensorFlow inside your machine. pip3 install TensorFlow, and it'll by default it will install the latest version. Mind you, in MacBook M1 versions, M1 MacBooks, TensorFlow has some of the other hardware issues, so it is not yet perfectly working. But in other MacBooks and in Windows machines, this will be perfectly fine. This will be perfectly working. So that's the case study. That's the use case for masked and unmasked uh, uh, video. And thank you so much, and we'll see in the next class what all projects or what all we can come up with, what all ideas we can come up with regarding this Google Teachable machine, which can just minimize the effort of generating the models using high level of code and long math problems. So see you in the next class.